So in this video, we're going to discuss marginal cost and revenue. And actually what we're going to notice is that these things apply directly to the derivative. And so in this slide, we're going to discuss how exactly that is. So hopefully you recall, we've actually previously defined these. The marginal cost is the cost to produce one additional item. Now recall, the rate of change tells you the amount of change in the output for one increase in the input. So in other words, that's essentially saying the same thing. That if you produce one additional item, right, you add one to that input, what happens to the cost or the output? So this means that marginal revenue is the same thing as the slope at a particular moment in production. This is written as MC or C prime of Q, because it's really the slope at some particular Q. Marginal revenue has almost the same definition, but instead we're talking about revenue. So marginal revenue is the rate of change at a particular moment in production. We write that as MR or R prime of Q. So just for example, we know that marginal revenue and marginal cost is equivalent to the rate of change. And just to review, rate of change is the change in output over the change in inputs. So ideally, we'd like to be able to calculate the slope at a specific moment or the derivative at that moment. But sometimes, remember, we can't get that exact information, so we use an estimate by looking at the rate of change around it. So it costs $5,145 to produce 1,015 items. It costs $5,325 to produce 1,035 items. Approximately, what is the marginal revenue for 1,025 items? So the first thing that I would say, well, we're considering 1,015 and we're going to 1,035, and conveniently 1,025 is exactly in the middle of those two items. If you notice, this would be add 10 to get to this, add 10, so we're exactly in the middle. So we don't know exactly at that moment, 1,025, what's happening. That's why this is an approximation. But essentially what we want to know is the slope, or what's happening around it. So I would guess that the marginal cost is approximately the slope around that point, or the rate of change around that point. So we want to look at the change in output. The output would be cost. Over the change in inputs. The inputs would be the items being produced. And so when we calculate this number, we get 9. In other words, we're estimating the marginal cost is $9 at 1,025 items. In other words, we think that at 1,025 items, each additional item is costing us $9. So I want to consider what's happening here graphically, and we're going to do this actually with a revenue example. Let's say we're looking at the revenue for some company. So we're inputting Q, the number of items, and out we should be getting the revenue. So let's say just for our purposes, we're going to consider 10, 20, 30, and 40 items produced. And we're going to look at this axis, 1,000, 2,000, 3,000, and 4,000. So the company begins producing items, and they're selling them, and let's say they come out and they're very popular. So the revenue goes extremely fast. But then as the item begins to sell, it becomes less popular. And so therefore they can't sell the item for as much money. And so we get some sort of graph that looks like this. So let's say we want to consider, is the marginal revenue greater at Q equals 10 or Q equals 20? So what I'm not asking do we generate more revenue? I'm asking if each additional item is generating more revenue. So what we really want to consider is the slope. We want to think about R prime of 10 versus R prime of 20, or the slope of the tangent line. Well, if I consider at 10, that would be the tangent line, versus at 20, at which one of those moments do we actually have a greater slope? The slope is greater at 10, so I would say R prime of 10, the marginal revenue at 10, is actually greater than the marginal revenue at 20. So we've considered what's happening graphically. Now we're going to look at some words and what these things mean in function notation. So let C of Q be the cost of producing Q items, and R of Q be the revenue generated by selling Q items. Let C of 100 equal 1500, and C prime of 100 equal 35. Let R of 100 equal 1750, and R prime of 100 equal 29. So we want to explain the practical meaning of this situation. So let's first consider what these two things are telling us. The C of 100 equals 1500 is telling us the cost of 100 items is $1,500. In each additional item costs $35. So that's what the cost is telling us. Now let's consider what these revenue numbers are telling us. So I would say R of 100 equals 1750 tells us the revenue for 100 items is $1,750. And each additional item generates $29. So what that allows us to do now is make some predictions. If we wanted to estimate the cost now of producing 103 items, C of 103. Well, we know the cost to produce 100 items is $1,500 plus $35 for each additional item. So 3 times 35. I would say the cost of 103 items equals 1,500 plus 105. That would be $1,650. So let's estimate the revenue generated by producing 103 items. R of 103 would equal 1,750 plus 3 times 29. So that would equal 1,750 plus 87, which would equal $1,757. So we want to think about what's happening here. Yes, as the company continues to produce items, the revenue should be increasing, but does it make sense for them to continue? I would argue no. And the reason is the revenue is being outpaced by the cost. Each additional item costs $6 more than the revenue generated.